Thank you, James. Well, welcome everybody. Welcome to today's webinar on the topic of detailed scheduling and planning. As James mentioned, I'm Greg Foskey. I'm the CFO at Technology Transfer Services here in Tampa, Florida. This webinar has been provided thanks to the Florida West Coast chapter of APIX, and we're going to cover a number of valuable areas in what will be a little bit less than an hour long, I hope. We're not going to be able to approach a level of detail that's available in the instructor-led program that James mentioned, but that'll be coming up June 18th. For those of you familiar with the Tampa Bay area, you can, it'll be up in the Carrollwood area. So go ahead and switch to that. Yeah, so it's going to be starting June 18th. Normally we would do this for 4 consecutive Saturdays, but because the 4th of July is in there, we're going to do it June 18th, June 25th, skip the 4th of July weekend, and then resume for the following 2 Saturdays. For those of you who are not seeking the CPIM certification, but you like what you hear with the webinar today, you're certainly welcome to be part of that class. We'd love to have you there. You can get more information from apixtampabay.org, or I've got some contact information at the end of the webinar as well. So a bit of a status update. In the prior webinars that I've put on, we've gone through from the basics of supply chain management on through the master planning levels. Today we're going to start the journey down to the detailed level of scheduling and planning. This detailed schedule and planning area is often called the execution phase of manufacturing resource planning. Today we're going to quickly cover establishing inventory policies that'll keep inventory investment down while still meeting customer needs. We're going to look at planning materials that support the manufacturing plan, planning manufacturing that supports the material plan, and I'll explain the difference during the webinar. Managing suppliers and their performance, we're going to dig into that in quite a bit of detail. Using planning techniques and tools such as material requirements planning, lean, theory of constraints, capacity planning, and project management. So quite a bit to cover. Before we dig into the details, there is a higher level that typically overarches these details at the plant level. At the higher level, lower level goals converge into corporate-wide goals. Inventory policies require valuation models. Performance metrics are implemented to focus groups on performance targets that are aligned. For tax reasons, shareholder investment comparison purposes, valuation includes the use of last in, first out techniques, FIFO techniques, standard costing versus actual costing, transfer pricing models. On the performance metric side of things, if it's not initiated at the top of the organization, at least the goals in the supply chain group need to be aligned with the corporation's total performance expectations. Today, while we're focusing on the details, we're also going to address some of the touch points between those details and the aggregate policies, including sales and operations goals, which I'll talk to next. Staying at the higher level for a minute, we're going to look at resolution of goals and objectives that sales and marketing has versus the goals of the operations group. As part of the same company, you would think that they were going to be perfectly aligned, but they're not. Sales and marketing's primary objectives are driven toward customer satisfaction. They want every order to be what the customer has asked for, when the customer asks for it, no exceptions. It's what we call shipping the perfect order. While the operations group necessarily embraces the same goals, these goals are oftentimes secondary to operations-based goals, such as employee efficiency, equipment utilization, and supplier performance. Of course, quality, safety, things like environmental and regulatory factors are always a consideration. So whether it be at the raw material and component level, a work in process level, or the finished goods level, management of inventory is crucial to have effective planning and scheduling of manufacturing. These include areas such as material identification, material packaging, handling and storage, and information management. It's critical that the systems data tells the true story of what's on hand, what's on order, and what's available. A key piece of detailed scheduling and planning is establishing inventory policies that minimize inventory investment while still meeting customer service objectives. What kind of inventory policies best fit your particular needs? What is your plan? Do you have policies being validated to assure that inventory investment is at the lowest level possible while still meeting customer expectations? Some questions, if you're getting into this and you're looking at developing your own policies, some things you might want to ask are, do I have my inventory prioritized? Have I put it into an ABC analysis, a Pareto model? Have I reduced my replenishment lead times where possible? Have I considered reducing my product offering? Sometimes that best serves the company. What about finding ways to reduce variability in both supply and demand? Do the expected timelines and transparency from others in the supply chain cover your needs? And do you communicate your supply chain metrics to others so that they're aligned with your company's goals and objectives? We're going to dig into those in a little bit more detail in upcoming slides. So the first bullet point is operating inventory. Everything beyond this first bullet point falls into a category that I would call managing by exception. A company can have excess, slow-moving, and obsolete inventory at the raw material component, sub-assembly, in-process, and finished product levels. This inventory can be housed in-house. It could be out at a supplier, or it could even be out somewhere in a complex distribution network of finished goods. It can be caused by faulty planning, customer demand changes, product redesigns, inaccurate data, or suppliers even having minimum order requirements. It's important to periodically look at this inventory and keep it cleaned up. Inventory accuracy is achieved through accurate storage, handling, and tracking. It can be audited by conducting periodic full physical inventories or cycle counting or both. In any case, each of these subclassifications should be properly identified, quantified, and prioritized in order to take action. So if we look at inventory policies at the item level, lot sizing can take the form of economic order quantities, fixed order quantities, period order quantities, etc. Safety stock and safety lead time as well are intended to cover variations in both supply and demand over a given period of time. Carrying costs, typically represented as a percentage. They cover warehousing and other related expenses, but it's important that they should also cover risk-related costs, things like obsolescence and theft. Beyond these three areas, there's also opportunity costs that need to be considered. What could the company be doing with the capital that's being invested in the inventory? Maybe hiring more people, buying more equipment, updating IT systems, improving their marketing campaign, or training employees. With inventory carrying costs in the double digits, good inventory management practices can save a company considerable expense. So on the last slide, I talked about the different types of lot sizing. Here I'm going to talk about the different types of ordering methods. These are going to be addressed in a lot more detail during the upcoming class, but the gist of it is that order point systems, they create an order signal when a certain inventory level is reached. So they tell the planner that the planning factors, the lead times, the inventory status All of this would indicate that more material needs to be ordered or reordered. Periodic review systems are handled a little bit differently. They're intended to look at inventory needs at given time intervals. For stable manufacturing environments, this would typically be done on a weekly basis. Planning for independent forecasted demand will be handled differently from dependent demand. Dependent demand is usually that which you throw into the MRP system. It's calculated off the independent demand forecast. Pull systems like visual review and Kanban also provide demand triggers. Where there's vendor-managed or consigned inventory involved, inventory ownership and management has a higher level of complexity. Reverse logistics plans, the last bullet, need to be added to the planning process when you have things like remanufacturing, restocking programs, you're using returnable packaging, if those things are involved. You can also see how these layers of management add a layer of complexity. So it gets very, very complicated along the way as you have different circumstances like these. Ordering methods can range from very simple, visual, like Kanban, to highly complex and integrated. Methods can include push or pull demand and can be driven by centralized planning groups or by using pull triggers received from point-of-sale devices. Either way, can exist in environments where a supplier ships direct to a consumer or uses a highly complex distribution network. So the next area, important in detailed planning, is planning materials in support of the master schedule. Processor-dominated scheduling is a technique that schedules equipment and capacity first. It usually occurs in a work environment where capacity is relatively expensive. You have to worry about the equipment being loaded, and customer due dates can be a little bit more flexible. Planning factors include items like order lot sizes, lead times, safety stock, scrap factors. Inventory status data includes on-hand balances, allocated quantities, and scheduled receipts. Historical data is an important element in the validation of forecasted volumes. Item numbering can be designed to be simple and easy to enter, or it can be more complicated. If you use a numbering system that provides more meaningful data, we often refer to it as using an intelligent numbering system. On the other hand, operations can be planned in support of a materials plan. Material-dominated scheduling is a technique that schedules materials before they schedule equipment or capacity. This is typically the case when operating capacities are not considered to be an issue. Whether material-dominated or processor-dominated techniques are used, schedulers must begin with a list of end items that the company plans to produce in the near future. This list is the anticipated build schedule and is referred to as the master production schedule. So we're going to look at a specific part number. You can see part number 10584 here. This is what you would refer to as an item master. On the master production schedule, once it's complete, there's a handoff into the MRP system. It's in the MRP system where we establish and maintain priorities for components and assemblies. As an example, on this single point item master, up on the top you've got planning factors like order quantity, lead time, that type of thing. Status data, what's on hand, what's on order, what's available, what's on hand and on order less what's already been allocated. And then you see a transaction history here as well. Beyond all of this stuff, beyond the item level information, I guess, are other essential data sets that need to be developed for a time-phased plan to be most effective. These are things like the routing, the in-house parts routing, and bills of material. All of this information is important in both a processor-dominated and material-dominated scheduling environment. So here, a little different visual on how the MRP system works. A little bit more down on the details. MRP starts up at the top. You see the master production schedule. What should be produced, how many, and when. This feeds the demand information into MRP. It then compares it to the bill of material that you see on the left to see what's required. Bump it up against the on-hand and on order amounts, which are the inventory status items that you see on the right, and the planning factors like lead time and safety stock. Put all this together based on the required date and part lead time. MRP is going to do what we call a gross to net calculation and put out a message to order, to expedite, maybe change an order quantity, or even if you've got something on order that isn't needed due to a demand change, you would even de-expedite some things. So material planning has different characteristics in different production environments. In a project-oriented environment, parts are typically pulled into a specific location. Big projects, big construction projects, space shuttles, stuff like that. In a lean flow production environment, there will be a different set of workstations that need to be filled. So you're going to be pushing parts out to different locations in order to complete the finished product. Kanban and pull procedures would be appropriate in a lean environment, but not likely in a project one where products are engineered to order or made to order. Planning parameters such as the length of time for each time bucket. So if you're planning in daily time buckets, short time, weekly, out in the near future, monthly and quarterly, further out, what's the replanning frequency and the total lead time? These all play not critical, important roles in material planning. Once the material is identified as needed for a particular work order, it's allocated in the system so that it's not considered to be available for other work orders. This is something called pegging, and eliminates the accidental overallocation of the same item to multiple requirements. So as materials plan throughout the year, planning parameters such as lead time and scrap factors may need to be updated. The MRP system may need to be integrated with many other systems. We've got CMMS, equipment maintenance management systems, logistics planning systems, warehouse management systems, supplier relationship management, human resources, distribution, DRP systems, and more. With a system integration and use of core data by other departments in their own decision-making activities, the responsibility of the planner to maintain timely and accurate information is compounded. So in a closed-loop environment, the relationships are not only with other systems, they're also with other departments. Closing the loop requires relationships and timely communication with these other departments for needs like capacity planning, engineering, purchasing, production, marketing and sales, again, HR and IT. Sometimes you can see from the illustration here, sometimes you've got companies that operate in silos. Some have open door policies. Some have brick walls. They don't communicate as easily. Sometimes it's easier to establish good working relationships with suppliers than with some internal departments that may break themselves off. Opening, reporting, and lines of communication are critical inside and outside of the organization. So here we move into an area of project management. APIC says project management is an endeavor with a specific objective to be met within predetermined time and dollar limitations. So as the APIC's definition indicates, A project is something that is not ongoing. Rather, it has a predetermined duration and budget established in order to complete a set of tasks. Once a project has a scope, priority and approval have been achieved, it's time to plan and execute. So this is where we're getting into the project side of this execution phase. This involves giving out roles and responsibilities, making sure that we've got scope alignment without scope creep and things just getting out of control, and due dates for individual task completion. It also requires that you've got a solid leadership skills for the area of project management that may not necessarily be the same skills that are used in normal day-to-day process management. Whoever leads a project like this, whether it's an ERP implementation, new capital equipment in the production operations, they need to have solid leadership skills, but they also need to have a good understanding of the task interdependencies. So if we've got some task lagging its time schedule, we know what the consequence is, whether it's going to have an impact on the critical path. When the project's finished, normally a final project report should be created and distributed. It should include a post-execution financial summary. So we look at it and we say, here was the budget, here were the actual expenses, did we hit the numbers or did we not? And even then, at a later date, when everything has settled into its normal state of operations, maybe 6 months down the road, performance can be reviewed to see whether or not the returns on the project investment were continuing as expected. So we also need to look upstream to our suppliers and make sure that we're managing the supply of both products and services. This management includes understanding suppliers' planning techniques, their capabilities, their historical performance. As this chart shows, up at the top, two-way information flow is very important. It's also valuable to know what potential trends and threats your supply base may be encountering. These may have an adverse impact on you in the future with their inability to service your company. They won't. The thing with some of these issues is they won't necessarily be reflected in historical performance data. So you can't just rely on historical performance of your suppliers to be indicative of what they're going to be able to do in the future. It's also a good idea to understand who your suppliers are. In a very solid supply chain partnership, information from the company is often allowed to flow back 2 or 3 supplier levels. What this does is it ensures that everyone along the supply chain has the same information and that they're synchronized in their efforts and avoid a phenomenon called the bullwhip effect. So this quad chart shows that different items and different suppliers should be dealt with differently. It breaks supply base up into 4 quadrants. On the x-axis, it has low to high costs, and on the y-axis, it says market complexity. I would call that risk along the y-axis. So items that are critical to your operation in the upper left-hand quadrant have a relatively low cost. But the question you should ask here to define your low-cost critical suppliers versus your low-cost tactical suppliers is this: if I had to do away with this supplier tomorrow, would my product line where I use the material survive? So efforts should be put in place to move items and suppliers in this critical quadrant into the tactical quadrant. Ways to achieve this could include component redesigns or increasing supplier collaboration activities. An example of such an item would be a custom designed gasket. Your engineers came out with a brand new product. They want to make sure that everything is really cool. They custom design a gasket. But as you go through, you may find that it could be replaced by a standard off-the-shelf gasket, or even if you redesign the finished product, you could replace it with an O-ring. So going up into the strategic side of things, an unresponsive strategic sole source of supply can have a devastating impact on an operation. These suppliers represent the highest risk and should be related to accordingly. These suppliers should be dealt with on a partnering basis if possible, so that goals and expectations are transparent and aligned between your company and theirs. On the other end of the spectrum, getting down into the tactical area, a supplier of common hardware items can easily be replaced. These are your suppliers like Grainger, your Grainger catalog, Reba. These are your tactical suppliers. Suppliers of high cost or engineered items that are not sole sourced are your leverage suppliers. A supplier in this quadrant who has an interest in securing your business for the long run may do stuff like provide supplier managed inventory services, or give you consigned inventory where they only charge you when you use the materials that they provide. Another option to this whole quad chart is that if you have in-house capabilities, or if they can be developed, produce the items in-house. So do a make-buy analysis, and if you see that your costs are creeping up from your suppliers, or you're getting into a sole sourcing situation, evaluate whether or not you want to bring it in-house. It doesn't mean that you can't go back out of house in the future. If the company moves production in-house and has issues, they can temporarily outsource some of their work. Companies typically do this during seasonal demand surges, spikes in demand, or when equipment, labor, other internal issues arise. International sources have their own set of complications. The further away from the supplier is, the more difficult it may be to establish strong working relationships. Going overseas, this is due in part to language differences, cultural differences, regulations, time zones, long lead time items with the inability to reschedule. Something's on the water. You got it in a container on the ocean, and you're not going to be able to pick it up and air freight it like you may be able to pull something off of a truck and put it onto a plane. It's not only important to share relevant parts of your company's strategy with key suppliers, it can be quite beneficial, because as they better begin to understand what your wants and needs are, they're going to be able to perform better to your ongoing expectations. So a good way to compare and critique the performance of your suppliers is to use a Supplier Certification program. As I showed you earlier in the quad chart, different suppliers may have different requirements for performance. Some may be providing critical materials. Others may only be providing simple services such as lawn service. So this information is important in order to compile it by supplier in order to develop the best certification program for each one and for your company. In the more complex environments, one size doesn't fit all. In some cases, some suppliers, like ones in the tactical category, may be exempt from the certification program. So you need to consider best fit for your particular company. Once a supplier has met the criteria to become certified, it's important that you maintain the certification process and review their performance, not only internally but with them. Go out and audit, look at the operations, look at their books. Depending on the specific performance criteria, you may want to even review it on each shipment of material. In a lot of cases, you'll look at an annual audit where you'll send out your financial folks, maybe your manufacturing engineers, quality folks, depending on how important that supplier is to you. Supplier performance can be measured on how well they meet delivery and quality requirements, but again, equally important to for long-term suppliers is that they have a strong financial position. You can look at it, they can be doing a great job over the short run, but you're not aware, it's not as transparent that maybe they're beginning to hemorrhage cash. They got another major customer, and they're refocused on a different priority of keeping the new customer satisfied versus you. It's not uncommon to request bank references for strategic suppliers, and periodically get copies of their balance sheets, P&Ls, things like that, cash flow statements. A supplier who's not financially viable is not likely going to be there for long. Of course, it's also critical that strategies between the companies are aligned and that they're not at cross purposes. So I mentioned it earlier, it's very important to make sure that your mission statement, your vision, your goals, as appropriate, are shared with key suppliers. So finally, we take a quick look at some other tools used in planning, such as capacity requirements planning, lean, theory of constraints, and project management. We talked a little bit about project management earlier. With these tools, your company can further refine or improve your processes in order to maintain or gain a competitive advantage. So on capacity planning, while capacity is considered throughout the manufacturing planning and control process, now that we're down into the execution area, it's specifically called capacity requirements planning, or CRP. CRP ties in with MRP. You've got all sorts of resource planning up at the higher strategic levels that feed down into this level. But now that we're in the execution stage, CRP is where we play in the capacity sandbox, if you will. It has the biggest impact on day-to-day execution of the master production schedule, and it has the most detail of any of the capacity plans. CRP program can simulate the planning schedule, go in, make the modifications in a simulated work environment, and create a load versus capacity comparison. Planner can identify conflicts, work to resolve them, and then go ahead and push that out into the live system. It's at this point where the operating plan is prepared for execution. So as mentioned earlier, capacity planning is not as critical in a material-dominated environment. In a process-dominated environment, however, capacity is considered finite, and operations need to consider this limitation. So we all know that the optimist sees a glass as half full, while a pessimist sees it as half empty. A lean thinker, on the other hand, wonders why there's so much more capacity than is necessary. So lean has a lot of concepts. Lean concepts like the four shown here promote the elimination of waste. Right-size the glass, if you will. Reductions in lead times, increases in flexibility of your production systems. They require less work in process inventory in order to produce the same products. Lean encompasses many more tools and techniques than the four displayed here, and they're used to improve performance in the three critical areas of improved operations efficiencies, inventory objectives, and improvements in customer service. Excuse me. So in most cases, theory of constraints, lean initiatives, Six Sigma programs, and other similar programs are aligned in their efforts to improve processes and reduce waste. It's important to select the right target opportunity. This is what you see in the roof area. This may be done using various prioritization models, where we look at the situation and say, what what of all these problems are we going to try to solve. So the roof is supported by two equally important columns, process improvements and personnel development. Some details are shown here in each one of those columns. At its foundation, lean transformation is supported by drivers such as mutual respect, problem-solving tools, time-proven techniques. At the center of it all is management systems and program leadership. Those of you that are familiar with DMAIC, just like in a Six Sigma DMAIC model, starting with a definition of your needs, looking at your as-is situation and your desired or your to-be situation, will prompt you to look at what actions are going to be required, what priorities, what roles and responsibilities should be handled out. Leading a big transformation and not just a single Kaizen event requires that your team grow in their abilities. This is enabled through strong program leadership, a knowledgeable cross-functional team, and the establishment of clear objectives. So I burned through these, I think, a little bit faster than I expected. I hope that we got through everything that everybody was looking for. We're at the end of today's presentation. I can answer any questions if you'd like to chat them to me. I don't know, Lindsay, is there anything on there? Okay. So I realize that the contents of today's webinar may have been a bit overwhelming for some, maybe just glossing over them as quickly as we did. We covered inventory policies that keep inventory investments down while still meeting customer needs. We talked about planning materials that support the manufacturing plan. We talked about planning manufacturing that supports materials plan. Supplier management techniques, certification programs, that type of thing, making sure you've got communications that effectively drives down to the lower levels of your supply chain. Planning tools, MRP, lean, theory of constraints, capacity planning, project management, the things we just went over. In the upcoming class, the 4 classes, we're going to discuss these in a lot more detail. On top of other issues, we're going to talk a lot more about capacity. We're going to address total cost of ownership in quite a bit of detail. We're going to drill down into the definition and selection of operations metrics. We're going to look at formulas, do a lot of practice exercises, case study, formulas and decision-making tools that are the outcome of using those formulas. Different systems, we talked about a few of them, I talked about a few of them during the webinar. Working in different manufacturing environments and how a lot of these planning factors integrate into the different work environments. Risk analysis, we'll get into that just like in the upcoming management dinner meeting. Risk analysis, we'll talk about that in more detail. And meeting environmental and community requirements, the sustainability projects that a lot of companies are expecting to implement now. So that's it. Also a quick plug, if I may. James mentioned I'm going to be the guest speaker at this month's APICS Tampa Bay Chapter Top Management Dinner Meeting. It's going to be over at Bascom's in the St. Pete area by the St. Pete Airport. And I'm going to be addressing the growing complexities associated with supply chain risk management. A lot of things are coming at us, a lot of stuff as we integrate ERP systems, as we become more transparent in our wants, needs, our data sharing. So for more information on this, you can see the email address up there bolded. It's apixtampabay.org. If you have any questions on today's topics, you can contact me directly. The number you see there is my cell number, and gfoskey@techtransfer.com, or if you want to take a look at our website as well.
I did have a question. Is the presentation available on the APICS site? James did say.
Yes. Yeah, the presentation in PowerPoint form. You know, it's not going to be available as a card deck of slides, but this is going to be available with all of my eloquent verbalization of you know, the content on the website. So that it'll be at apextampabay.org. So everybody, thank you. I hope you enjoyed it. I look forward to seeing some of you in the upcoming class. Okay. So thank you.
Greg, this is James. I just want to thank you again for this awesome presentation. There's quite a bit of information here, so I can see how some would be overwhelmed with some of it, but thank you so much to you and Technology Transfer Services. And for those who did ask about the presentation, as Greg said, it will be available on the website. Just go to apextampabay.org and select the submenu that says Webinars, and you will see this presentation tomorrow at the latest, but hopefully we will have it posted today, as well as the previous presentations that we have done this year.
I'd also like to throw out a